Hello everyone, welcome to Technical Campus. And in the earlier videos, we have learned the concept of slope, how to calculate the slope of a given line, and we have also learned how to use differentiation method in order to find the slope of any tangent of any curve. So let us define the term differentiation in the term of slope. So we may write that differentiating means finding the slope of any line or tangent. Please learn these things carefully because this concept will be used in mean value theorem. Okay, so before learning the mean value theorem, you have to know this concept. So let us quickly learn all these things which is necessary to understand the concept of mean value theorem. So we can say that differentiating means finding slope of any line. So suppose we have a function f of x, and if we draw the graph of this function, the graph is look like, suppose the graph is look like this, and suppose the graph is started here x is equal to a and the graph finishes at x is equal to b. Okay, so we can say the range of fx is a and b. This is the notation of closed interval. That means the value of x is included a also and b also, and this is the notation of open interval. This means suppose it is written as x belongs to open interval ab, it means the value of x lies between a and b but excluded a and b. Okay, the value of x is excluding a and b, but in this case the value of x is including a and b and in between a and b. So we can write the value of the function f of x is lies in the domain a and b. Okay, so suppose we have function f of x and we have drawn the graph of the function f of x like this. So you can see the graph is continuous in nature, because if you observe carefully you can see in between a and b the graph is continuous in nature. There is no point of discontinuity here, so we can say the graph is continuous between a and b. Continuous. Now let us learn this concept. Okay, we have seen that differentiating means finding the slope of line. You may use this as a definition of differentiation. Okay, so if we draw the tangent for this curve, then we can say that this curve is differentiable in nature. If we can draw the tangent in anywhere in this curve, you can draw the tangent anywhere in this curve. Okay, tangent means when a straight line passing through a single point in any curve. Okay, this is the concept of tangent. So you can draw the tangent anywhere in this curve between a and b. Okay, because there is no any single point in which you cannot draw the tangent here. Okay, so if you can draw the tangent, you can also find the slope, and if you can find the slope, then the function must be differentiable. So we can say the function f of x is differentiable in nature because we can draw tangent anywhere in this graph. So if it is possible to draw the tangent anywhere in this graph, then we can say the function is differentiable in nature. So this is the criteria to be differentiable. Okay, in the graph of this function, it is possible to draw the tangent anywhere. Okay, if there is any single point in which we cannot draw the tangent, then we will say this function is not differentiable. But in this graph, we can draw tangent anywhere in this graph. Okay, anywhere you can draw the tangent anywhere. So the graph is differentiable at all point. Okay, because we can draw the tangent anywhere in this graph. So let us see another example in which we cannot draw the tangent. All this concept will be used in mean value theorem. So guys, please learn all these things carefully. Okay, if you feel any problem, please comment below so that we can clarify your doubt. Suppose we have a function which is like this. Okay, we have a function f of x, and if we plot the graph of f of x, it will be look like this. So you can see, suppose this point is x is equal to a and this point is x is equal to B. You can see the graph is continuous in between x is equal to a and x is equal to b, because there is no point of discontinuity. But if you observe carefully, in this point, although the graph is continuous, this point is not differentiable. Why this point is not differentiable? Because according to this definition of differentiation, that if we can draw the tangent anywhere in this graph, then we will say the graph is, or the function is, differentiable in nature. But in this graph, you cannot draw the tangent in this sharp point. Why? Because according to the definition of tangent, when in any curve a straight line passing through a single point, means for a single point there is a unique tangent exists. Okay, if you take the microscopic view of this area, for any single point there must be a unique tangent. Okay, for every single point there must be a unique tangent. But suppose there is a sharp point and this is the point, so you cannot draw a single tangent here. This point belongs to many tangents. You can see, you can draw the tangent here also, here also, here also, here also. So the number of tangents is 1, 2, 3, many. So geometrically there is no unique tangent we can draw at this sharp point. So in sharp point we cannot draw the tangent because it is violating the definition of tangent. According to the definition of tangent, every tangent must be unique to every point. Okay, so in the case of sharp point, there is not a single tangent exist. There exist many tangents. So we can say we cannot draw tangent in any sharp point. So if there is no tangent, then slope of this point cannot be calculated. So if the slope of this point cannot be calculated, this point is not differentiable. So we will say the function is not differentiable. Okay, so the function is not differentiable. As we cannot draw the tangent here, so we will unable to find out the slope here. So if we cannot find out the slope, we cannot say this function is differentiable, because according to this rule, differentiation means finding the slope of the line or tangent. So here the no tangent means no slope, means not differentiable. So you may learn this thing as no tangent means no derivatives. So please learn these two key things. Okay, first thing is that differentiation means finding the slope of any line. If we can draw the tangent, we can also find the slope, then we can say the function is differentiable. But if we cannot draw, we cannot find the slope, so we cannot say the function is differentiable. So if in this graph we find any single point in which we cannot draw the tangent, then we will say the function is not differentiable. So you can say, although the function is continuous in nature, but this function is not differentiable, as because there is a sharp point exists in which we cannot draw the tangent. So if we cannot draw the tangent, we cannot find the slope of that point, so we cannot say the function is differentiable according to this rule. So the function is continuous but not differentiable in nature. So we have already learned, if a function is differentiable, it must be continuous. But if a function is continuous, it may be differentiable or may not be differentiable. So here is the proof. In this domain x is equal to a and x is equal to b, the graph is continuous in nature, because as there is no point of discontinuity here. But the graph is not differentiable because there exists a sharp point in which we cannot draw the tangent. As we cannot draw the tangent, we cannot say the function is differentiable. If in this curve there exists a single point in which you cannot draw the tangent, then the function will be not differentiable. So these are the two key things which is applicable for this. Okay, so we have learned all the necessary things, we have learned all the necessary criteria to understand the mean value theorem. So let's start the mean value theorem. Okay,